Okay, great.
Ola.
Jerry's here.
Eh?
Uh,
That Ola? Hmm? It's on me.
I was talking about, I'm inviting you to this topic because each of you have excellent approach to this thing called the system thinking or cognition or consciousness. Uh, I have a little contribution myself after long years that I call it a four-dimension uh, system thinking, four dimensions. So I have to explain why four dimension and what are the four dimension. So let me share my screen. Should be this one and share. Uh, so did you have that? No?
Yes.
Okay. So my topic will be just uh, starting from a very fuzzy and intentional, like the concept of rationality. Okay, be rational, don't be too emotional, things like that. So our brain moves towards this direction to being rational, and then later, after Galileo and Newton, we had this thing called the scientific thinking. So it's on the extreme side of rationality already. So it's kind of an achievement of rationality. And then the science developed into our age. We got this thing called the system of thinking, which is not as narrow as the classical traditional scientific disciplines. It it aims at the effort of combining things together and seeing more and seeing a whole, and the whole is larger than the sum of the parts, etc. So this is the direction we step into conquering something we call a complexity. Uh, so that's the arrow of directions. Uh, so responding to previous, responding some of your perceptions, like Jerry's ideas, like Ram's idea, and Osman's ideas. Oh, ego is here too. Ego's ideas. Uh, so, uh, so I'm making a proposal of a thinking tool. So that's the that's the general. Okay, so I've covered that. The green part is what we call thinking, and rationality is a smaller, is a subset. Scientific is even more subset, and the systemic is at our core. So according to a conversation for Grok or the XAI team dataset, about 10 to 20% of our human beings are rationality driven. So it's not that not everybody. System thinking is not for everybody. So we can be realistically focus on this 10 to 20%. And smaller than that, 3 to 8% of a global population is capable of consistently applying scientific thinking. So, so a smaller set as well, and 2 to 6% of people is capable of consistently applying system thinking with specialized interdisciplinary tools beyond regular standardized scientific methodologies. So that's why we have been promoting this project named the Oxford Project. We target not everybody, not the whole human being, but we target providing education for system thinking or now we call it SCI, combination of systemics, cybernetics, informatics, etc. Provided that literacy to just 0.01% of our population, and that was 800,000 people. So can we do that? That is some context, background information. Now, I had this little interesting definition of science other than Popper and Maturana. I just simply use the 7 letters to characterize what needs to be science, what qualifies to be science. So I put system thinking at the very top, because starting from Newton, the element of what he's talking about becomes 2 or 3. So it's the elements versus the relations. So actually, you have to be system thinking if you want to do science. And the cybernetic structure, even cybernetics, emerges pretty late than Newton's time, Einstein's time. But the focus towards the causalities, turning its back loop, forming causality recursive functions, the recursive procedures, is a unique perspective. So they need to go always with the system of thinking. And a little bit later, idea of information and the information processing and all the information related phenomena like culture is becoming another field of a study. So my proposal is, okay, it's time that we put all these things together to create something in like a trinity. And then, of course, you have to do experimentation. You have name your hypothesis, and you have to communicate with the colleagues, and eventually leading us into coordination. And then the engineers need to create new stuff, like rockets and cars, etc. So I'm selling this little new definition of science to you to see perhaps it is a better complementary idea than the old ones. The old ones, I would use Popper as the first one. And his scientific definition is the cycle here, problem situation and testing theory 1. And explanatory eliminate, he called error elimination, first step. And then after you did these 3, you are entering a new area called the problem situation 2. So this goes on and on. This is a Popper's perception. And Maturana's perception is substantially similar, but his representation is different. Describe a phenomenon 1, and then you have experimental explanatory hypothesis formed in your mind, and then you have to use your hypothesis to derive, this is not description, derive another phenomenon, like making a prediction, like Einstein making the prediction that the light would be curved by the mass of the sun, things like that. So then you make your second observation to either confirm your previous hypothesis or to falsify your hypothesis. So that's another cycle going on. I have improved them a little bit to this easy to understand circle. You make observations. You think of interesting questions from your observations, and then in order to answer your question, you formulate your hypothesis, and for the hypothesis, you develop your testable predictions, and then you go to the reality to get the data to test if whatever you're saying makes sense or not. And a lot of academics stopped at this stage. They just keep talking about here and never move this step. But this step is so important then because only after that you can refine or change or expand or reject your own hypothesis. And this goes on and on until you develop a satisfying general theory, accepted by your colleagues and accepted by the public. Then you keep going to the next step. So that is some kind of a review or connection with the predecessors. So why do we, when we doing actions in the real world, many times we fail to achieve our goal. So here, I perceive failure equals a lack of knowledge. So if you fail something, something is missing in your knowledge base. A lack of knowledge needs error correction, feedback, and the error correction equals one, you're back to standard, two, you're back to custom, you're back to convention, you're back to common sense, and then you question your assumptions. Therefore, the premise of questioning equals recognize or acknowledge our fallibility. My feeling is a lot of our colleagues do not or trying to avoid checking our own fallibility, which means there's no absolute truth, and truth exists relative to the specific problems, and problems are endless and ever emerging. It's kind of a dynamic image that you just cannot be settled on forever. So our attitude of ourselves discovered some fancy silver bullet theory that will solve the whole world's problem. That needs to be given up. Okay, so information that can solve problems qualify as knowledge. Knowledge is a temporary explanation for the time being, including what I'm going to talk about later. This is a little review of my category of 4 types of science. I'm currently only focused on science 1 and 2 and not touching 3 and 4. Yeah, many of you already seen that before. So making this proposal another background is that I think it is time that we assemble these 3 armies into 1 army. The 3 armies, namely system science group, initialized by Bertalanffy, and the cybernetics group, initialized by Wiener, and the whole cybernetics group. Our ASC colleagues are very fancy of all these founding fathers, including Hanson Forrester and Maturana, blah, blah, blah. But I feel a strong urge that we need to stop talking about our own pioneers and start making connections with pioneers in other fields. For example, Shannon's information science group, they are currently running a mailing list called FIS on internet, pretty active, a lot of good in discussion, but they are not aware or they are not familiar with literatures in cybernetics and the systems. So making this bridge is very important. I've been trying to engage with conversation. Or Lou Kaufman and Jerry had more talks there. Now, this is a little summary that AI helped me to put together. Just two simple table. So for the informatics, you have Alan Turing from Neumann, Shannon there as a representative. For systematics, you have Bentolante, Brodin, Rappaport, and Rolf Grau. And for cybernetics, you have these familiar names here. And they have a little bit of different focuses, but they have largely a large set of shared concepts. So I love to use this analogy or metaphor of Gaudi's new church, supposed to be accomplished next year. And this church, I was there very much amazed by it. It's got three entrances. Not four, but three. The fourth side is a wall, is a window wall. Now, three entrances telling people different stories of Christianity. So I think systemics, cybernetics, and informatics, if you enter the field, you run into a lot of the same things inside the building. So I would promote to use Gaudi's church as a metaphor of unifying these three fields together. They are actually the same building. So this is a little detailed explanation of Gaudi's idea. You don't have to worry about that. But the point is, none of them can really make sense without mentioning the other two or the contents from the other two. So we need a powerful story system, a powerful body of knowledge unifying all of them. Those are my background bragging. Now, I see all the theories, any theory promoted by any one of you, and this current theory promoted by me here, I saw them as all tools. So you see, you have a telescope, you have a microscope, so you can have cystoscope, you can have a cyberscope, you can have an infoscope. As long as you create a usable standard procedure for the user, not the researcher. Okay, if you are in the research mode, you are running wide, you are running creative, you are running crazy. And sometimes you just talk to yourself and people won't listen. But if you are in an application area, you have to have something that a newbie or a non-researcher can say, hey, this is a good tool. Let me try to use it. I challenge all of us to develop our good ideas into usable tools. So that's why I'm proposing, number one, to join these three fields, make some summary of them together in a format for a teaching curriculum. And before that, I had proposed a taxonomy of system thinking, which is a collection of various kind of doing system thinking by different schools of thought that I put them in a structure, a building structure, a first layer, second layer, some of you are familiar with. And after that, my own proposal or my own invention, whatever you call it, or contribution, is this 4DST as one of the SCI scope. Okay, so here, this is an AI altered picture of myself, so that I can say some slogans or quotations here. When Feyerabend said science is anything goes, I add the second half, as long as if you can develop your theory into a tool that benefit people. So a little marketing. This is the review of that 10 layers, 10 levels of a system thinking. Okay, you start from a very simple shopping list, finger counting type of system thinking. And then you start building causality tree or fishbone diagrams, and that connect a lot of variables, like accountants connecting all the accounting variables into a spreadsheet. But a spreadsheet does not have cybernetic feature. So starting from the third level of system thinking, you start considering circularity loops. That means you start seeing feedback, feed forward, and later I push it into feed up, feed down, and even feed left and then feed right. But above circularity, you pay attention to self-organization mechanisms. It needs some time to let you see the result of self-organization, but the self-organization relied on unchanging principles or unchanging algorithms that recursively applying to the system or happening in the system. So once you understand the self-organization, you are at the fourth level. Now, self-organization is not only just one case. In the real world, in our reality, we have multi-layers of them applied together. And in the same ecology, we have multi-agent, multiple different processes of self-organization going on. Or for example, ecology or evolution, or even politics. Okay, different groups, different interest lobby groups working on different agendas, fighting with each other. That's multi-agent. But when the system become more and more complex, especially when we're talking about life, and Hans von Forst pointed out a turning point is a machine becomes non-trivial. So every previous industrial revolution machines are trivial machines because their output is always determined by the input. And if you don't change the input, output is always the same. That's trivial machine. But something called memory happened in human brain. And once you have memory, your behavior, your transfer function of next time is different from the previous time. So Hans von Forst attributed this non-triviality to explain the amazing creativity that human beings or animals display. That is because the system is entering into a higher level with the memory. And now artificial intelligence systems are entering here too. Okay. Next level is self-guiding. That means it's not only a memory you have formed inside you. You have formed an internal model of the world, of your environment. So that guiding you to behavior, to effectively. So self-guiding is at the next level. And then another next one, self-goal setting. You have something called a purpose. Yeah. And become human here. And a better human can reflect their own mistakes. Self-reflecting is the highest level in previously existing system thinking schools of thoughts that I just put them together, and I use the 10-finger model to help people understand. So the student can easily just remember, okay, 1, 2, 3, 4, 5, 6, 7, 10, and that you become literate to 10 levels of a system of thinking. Of course, you need to unfold each one and learn how to play with them, how to use them. And you understand in what situation, which one will be work. If you go to supermarket, you don't need too much cybernetics. You just need a simple shopping list. A list is multiple elements. So that is your simplest system thinking. It is a shopping list. But so this is the taxonomy. Okay, back to my today's theme. What's common between a stone axe and this thing called SCI we talk about today? I think the secret word is still that word, tools. So for cognition, you have cognitive tools like a telescope is a cognitive tool, a microscope is cognitive, an X-ray scope is your doctor's cognitive tool to understand what's going on in your body. And so we can create a SCI scoop and teach them to people, teach it to people so that people can see things like a doctor seeing through the X-ray. And we also on the action side, earliest primitive one is a stick. It can use to strike, to hit a prey, or a predator, or hit a human being. And then we have stone knife and all the way developed to a Swiss Army knife. So we also can have a SCI 9. That means procedures of operations that follow SCI rules. So the previous 10-finger thing are tools developed by previous theory pioneers, and I'm adding this thing, the 11th finger, hopefully, and hope it is useful. Whether or not it's useful, you guys can decide. What I hope to add to the list is an experimental proposal to always check a situation where we feel complex from 3+1 dimensions, therefore named 4DST. And I have been talking about this since 24 years ago. Okay. Going back to history, the yin-yang thinking, two-element, two-dimension thinking, it proposed you, it suggests you to always concede the opposite and always consider the dynamics. So my proposal is simply add one here. So instead of consider two aspects of your object or of your system, you try to consider three aspects in the same time. I'm not the only person doing that. Our member Leo, who passed away 2 years ago, he had been talking about what he called what's his term? I forgot that word. But anyway, the 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 concept is if you can see things through 3 dimensions, it's very hard to add more. But the 3 dimension, you are closer to truth, so-called, because from a different perspective, this is a true representing the representation of this thing, and this is also the true representation of this thing. So 3 dimension is better than 2. I hope you buying that. So what are 3 dimension and 3 plus 1? Okay, my proposal is number 1, from the system tradition, it is the structure. So it is the skeleton of the stuff. It is the hardware of the stuff. And the second dimension from a cybernetics background, cybernetics focus, is the procedure. So feedback is the procedure. Feed forward is procedure. And the feed left, feed right, feed up, feed down are all procedures. And the procedures links into networks, chains, and you see, from a structured perspective, you have a static picture of the object you study. But from a procedure, you have a dynamic situation going on. So that's why MIT developed the system dynamics modeling to use. They have been trying to capture all the procedures into differential equations and feed them into a computer and simulate the whole thing as a way to conquer. But only these two is not enough. Not only because we have something called information focus, but also because we have this group of terms. We have a term called context, right? So for a whole situation you have to understand, you need to understand its context. Or for Hans von Forster used the word environment. So for me, they are all similar, same things like a pot of soup. It is like the taste of the soup, soaking your structure, soaking your procedure. But it's on a different dimension. So it is your operating system. It is your it is a very slow change part of the thing. This is quick change. This is unchanged. Okay. So this is the 3 basic dimension. Why 4 dimension? Because from the whole situation, once you settled the both structure and procedure and culture, you have something new generated, emerge from it through the self-organizing processes of the system. And that is on time dimension. So it's the 4th dimension. So that is the proposal of the 4 dimension, 3 plus 1, that if you can adopt, you can explain suddenly a lot of complicated things in simple ways. Uh, okay, word one, word two, word three, borrowed from Popper. But you can consider, because Popper says that we have three words, and the first word is the physical one, the natural one, the non-human one, including human biological body. Okay, so that's a physical reality, and word two uh, is a mind, language, is the everything inside our brain, and the word three is that everything mm, human artifact created left on this planet. So it's kind of a borrowing from him, and we also have our own word one, word two, word three as our structure, our procedure, and our culture. And Ram has been discussing with me about functions. My point is any function is a subset of some procedure. Of course, you can have a long procedure function, but when you talk about input, output, and transfer function, it's always one step or one micro step inside a large system. So I will insist to use procedure instead of use function. Otherwise, this framework is very similar, very close to RAM's kind of thread. Okay, this is a little bit of explanation. Uh, if you intentionally to see your system from structural dimension, you're thinking about things like these tools that can help you to discover the previously unseen structure, like a cancer, like a fracture of your bone, things like that. And from a procedural dimension, you measure this essential variables, like this is how doctor sees them patient, the heartbeat, the breath rate, the blood pressure. These are the procedure dimension. And the cultural dimension is that a long list of a lab report from your blood and your urine test. So each of them is one dimension, but they work together. So if you combine them together, you have a better diagnosis of if you have anything wrong with your body. Now, self-organizing dimension is the fourth one. It is the predictions or observations on the developmental pathway of a patient's health situation, without or with medical intervention. So, okay, so that's the core. Since I have been talking about this for a good number of years and accumulated a lot of examples and the cases. But I would like to hear your response, criticism, comments, suggestions at this point. I have another point just in case you want to dive into the details, but that's the basic framework that I'm going to say to you, any buyers. You're muted, Lori. You want to say something? We cannot hear you.
I was going to wait for somebody else to say something first, but okay. What comes to mind is you mentioned intuition as going beyond intuition. But if you look at the expert, what happens is the intuition reemerges at a higher level. The intuitive expert, Feynman said his thinking was imagination in a straitjacket. It's still imagination, still intuitive, but it's now in a straitjacket of factual thinking. So it seems like your emergent stage is this, it's an emotional thing of order within complexity, where you're returning to the emotions of elegance, structure, understanding, and then it's functioning intuitively again at that higher level.
Jerry?
Oh, I'm waiting for you to respond to Lauren.
You have raised your hand.
I know, but I'd like to hear your response to Lauren first.